So Amnon is probably you may not know, but he has been one of the most successful entrepreneur that came out of Israel. Hi, Amnon.
Hello, hi,
I am so glad you can join us in a very difficult time. As a friend, as a colleague, as a co-board member, I am just happy that you are there, safe, and being part of this journey. But I'm sure there's many things going in your mind right now. But despite all that, you're here. So let me give you introduction to the group, and then we can have you give your perspective on it. So just so that some of you may not know Amnon, Amnon has been a very persistent entrepreneur. I have known him for many years now. He worked on this idea of providing the eyes and the ears of a devices, especially automobiles, that can be able to provide automated driving possibilities. He is a professor in computer science and AI. That's his expertise. But he's applying that into in one of the biggest applications, which help us to drive better. So probably 80 or 90% of cars had their technology embedded using AI technologies and sensors, making the experience much better than it had been. It had one of the most successful IPO in Israel history, as well as the double actually IPO in the US, over $30 billion market cap today. So without too much information, what I'd like to do is have Amnon to talk about how did he start building his company over 20 years ago. So I'm going to tell you, it's not something just happened overnight. It happened over a long time. And I want to get Amnon's view around what it took to build a company like he did in Israel, and what are the investment climate is like over there, and how things are going over here given this circumstance. So Amnon, please go ahead. Thank you.
thank you, Young. So, the kind of question is this 24-year long journey. What did we do? What did we do right in order to make Mobileye whatever Mobileye is? I'll open this slide a bit. Okay. So just as context, Mobileye market cap of Mobileye today is about $30 billion. We have 3,500 employees. Annual revenue is about $2 billion and growing. But if I kind of look at those 24 years and try to isolate key decisions, they're all around bold innovation. Meaning trying to do something that others would advise you not to do. So, for example, our first innovation decision was to double down on monocular processing. Monocular processing for computer vision, where the industry and experts at the time were focused on stereo processing. Today, all cars that have driving assist, the majority, 99% of those who have, a camera doing driving assist, it's monocular processing. So next, we doubled down on making our own system on chip, our own silicon. That was back in 2001. So more than 20 years ago. Today there are many fabless companies, but 20 years ago, being fabless in the automotive industry was something unheard of. Thinking that a startup can supply a piece of silicon to a car maker was very bold, and even some thought was kind of foolish. Becoming a tier 2 supplier and working with all the tier 1 in a non-exclusive basis was also something quite innovative for the time. Now, we were also bold on the computer vision features. The industry wanted only lane departure warning. That's what they thought the camera is good for. All the rest would be done with the radar. And we gradually introduced forward collision warning on vehicles. Then we introduced forward collision warning on pedestrians. Then we introduced automatic braking on vehicles and pedestrians. Then we gradually removed the radar. The majority of entry-level ADAS today is only camera. There's no radar there. And then we ventured into autonomous driving about a decade ago, and we did that also in an innovative way, rather than copycatting, the LiDAR-centric companies that exist till today in this space. Mobileye took a very bold and innovative approach on focusing first on cameras, and then adding redundant sensors like LiDARs and radars. I think, we made also, key business decisions, we're very innovative, focusing on the bottom line. Since 2014, the company is profitable and remained that way even during the 5 years under Intel. So creating a viable business is a key driver, not only, developing cool stuff. And I think the advantage of, coming out from Israel is a pool of very strong engineers. It's a pool of A teams. And, the concentration of A teams here in Israel is very high. And building a tech company, you really want, the best engineers that you can find. And here there's a very high concentration. So I think it's not a coincidence that, Mobileye, even though there's no automotive industry in Israel, because Mobileye is a tech company, software company, designing chips, but at the end of the day, it's a software company. This is really the sweet spot of Israel.
So, Amnon, I know working with automobile companies, it's not an easy, right? It takes very long cycle. And of course, the managing the relationship where each of auto companies want their own unique architecture, unique solution, because they don't like to share. And yet today, 80 or 90% of all the cars have your technology. So it requires an incredible differentiation, innovation, as well as a business partnership that are unique, because you have captured much of their data to make your system better. And I'm just curious, how did you do that, given the difficulty of managing each of these OEM relationship?
I think that the key driver was to find a way to do a sublinear growth. Sublinear in terms of, the more customers you have, you don't want to grow linearly with the number of employees or the amount of resources you want to spend. So for example, a tier one grows linearly with the amount of customers. Each customer requires putting hundreds of people, near the customer's site, and this causes scalability issues. So one of the kind of, innovative thinking that we had at the beginning is how to create something that can scale, such that the amount of resources we need to put by entertaining new customers would grow sublinearly with the number of customers. So for example, we have 3,500 employees today, but that's very, very small compared to the number of customers. We have more than 50 car makers working with us. We have around 100 production programs running in parallel every year. It's something that's very, very difficult to do with the 3,500 employees unless you build templates. And you build kind of tuning languages on top of those templates, such that the customer feels that they own the driving experience, but the underlying technology is really shared among all the programs. Mm-hmm. So this is something that we spent a lot of thought how to make that growth in a sublinear manner.
Right. So because I'm actually involved in the automobile industry as a chairman of Harman. The tier one means the people that are adding integration for OEMs between the technology supplier. Very difficult work, and I think what Amnon has done is really change the paradigm by providing a platform with the customizable layers, stacks, that can be able to meet OEM's need. Now, a lot of people are excited about this idea of autonomous driving. Particularly Elon Musk has promised that in, I think, 2019. It's not here yet. So the question, I think, is probably in the room, where are we going with autonomous driving? Do you see that coming soon, or do you see that as something that's going to take time?
No, I'm very optimistic. And you need to define what you mean by autonomous driving. There are two main industries for autonomous driving. One of them is what most people are aware of is robotaxis. What Waymo is doing, Cruise, in which you are replacing the driver in a mobility as a service. You're replacing the driver with a robotic driver. From a technology point of view, I think that there are no open issues there. It's just a matter of how to scale the business. And you see those companies that are building robotaxis, they burn billions of dollars every year. And the challenge is how to scale this business and become profitable. The second industry of autonomous driving is just forming now, which is consumer cars. So imagine you buy a car and you have an eyes-off, hands-off, eyes-off system there with a certain operational design domain in ODD. For example, just highways. Once you're on a highway, you can legally have an eyes-off. You can read a book or something like that. And once it gets off the highway to an urban area, it will ask you to take over. And if you don't take over, it will stop on the side. These things are now already being sourced. So by 2026, a number of car makers, we announced already 3 or 4 car makers that we are going to supply this technology, are going to introduce these systems starting on highways and then later adding more types of roads like arterial roads and urban. So autonomous driving, or let's say eyes-off system, hands-off, eyes-off system, we're going to see them in volume during this decade. Whether robotaxis or consumer AVs, this decade is the decade of deployment of these systems.
Great. I'm sure I already driven in one of your cars when I was visiting you last May. Some really excitement in some of the technology advancements that are going on. I'm sure we'll continue to see that evolving. Last question for you, because I know it's late in Israel, but I do appreciate you joining. Clearly, we are in the top of excitement around AI topics. And given your background and you're one of the pioneers, really using not only involved in developing, but also applying and actually taking the market of these AI technology products. Tell us, where are we with where we are today, and how do you see it going?
Well, when you look at the large language models, the type of GPT-4, it's the leading one. It's not a hype. Based on what we know today, and this kind of AI can become a very useful assistant and automate many tasks involving writing, reading, summarizing, follow instructions, including tasks that require some creativity and ideation. But it's important to understand what they cannot do or what they are not designed to do. They have unique properties, some of which are not shared with humans. And pinpointing those, I think, is important in order to understand what is the next step. So the problem with the language models that are trained on, call this next word prediction over internet text. So this leads to some, I would say, surprising failures when there's a conflict between next word prediction and the task at hand. So for example, there is a sensitivity to task frequency. So a rare, simple task will have less of a chance to be solved correctly than a frequent complex task. So for example, researchers from Princeton, they showed that GPT-4 can handle the shift cipher, where each letter is shifted by a fixed amount. And the popular one on the internet is 13 places. It's called ROT 13. When asked to shift by 2 places, the performance degrades noticeably. So it's the same task. Instead of shifting 13, you shift 2, and then you see a very, very degradation in performance. There's also sensitivity to output probability, where the answer needs to be high probability text. There's sensitivity to input probability. All these things are not shared with human performance. Then there's the issue of abstract reasoning, the ability to form a rule from limited data. For example, researchers from University of Auckland show that GPT-4 does not perform well on abstract reasoning. And I would say that in general, language models are not good at bookkeeping. when you're solving a complex problem, you need to break down the problem into components, solve each component separately, integrate the results. Lots and lots of experiments show that these language models are not designed for a long bookkeeping. So now the question is, where are we going from here? And I think that we're witnessing the end of the first chapter of generative AI, where the AI is just one large end-to-end network. A query goes in and the final output comes out. The next phase is what I would call a decomposable AI, where AI engines would be applied to parts of the task. So you could have a super strong AI like GPT-4 dealing with the ideation step, and then more specialized AI engines to perform the bookkeeping during problem solving. So in order for AI to become useful as a problem solver, we'll need mechanisms to provide guarantees. So today you have no guarantee that the answer that you are getting is correct, or say the code that the AI would produce is, even if it runs, is it correct? In order to do that, we'll need some guarantees. People are trying all sorts of languages coming from a theory improving called the Lean to create verification. There's a lot of activity in that area, and abstract reasoning is something that would need to be solved. And I believe an end-to-end network is not the right tool. For that. So we are at, I believe, at a very interesting juncture of AI. What has been developed so far is very useful. Mm-hmm. It's changing all what we know about automating tasks, automating cognitive tasks, writing, reading, summarizing, even things that require creativity. But it's limited. It's not going to be a great scientist. It's not going to be a great mathematician, a great physicist. We're not going to have an Einstein or a Newton coming out from this generative AI, and that's really the next step. How do you create a great scientist coming out of AI? And this is something that is occupying a lot of attention among the research community, and I think that is the next step. How fast are we going to proceed? I don't know, but given the acceleration in the past 4 years, I wouldn't be surprised that in the next 5 years we'll have an AI that can solve really difficult problems that the best humans cannot solve.
Well, so very much exciting time ahead. Clearly, we're in the first phase. There's more coming. And I really appreciate Amnon joining us tonight from Israel. And I wish you safe. And I'm looking forward to seeing you again in Israel soon. All right?
Very good. Thank you, Young. Thank you. Bye-bye.